So I have my two equations. So let's determine VA and VB. Wait, I made a mistake.
Okay.
Summation of moment, not horizontal force. Summation of moment equal to 0. Is that okay?
Yes, please.
So I'll have my VA plus my VB, which they are both upward forces, to be equal to 30 plus 30. Do you understand?
Yeah, I get it.
So VA plus VB will give me what, 60.
Yeah.
Okay. So this is equation 1. Then your second equation is summation of moment equal to 0. Moment about a certain point equal to 0. So with this, you can choose to take your moment. You can choose to take your moment about this point.
Mm-hmm.
It
Let's take
depends
moments out.
about A.
Yeah.
So moment about A. So what is moment about A going to give us? You have the distance between this and that. You have 2, 2, 2. So wherever you take your moment, you consider the directions which you are considering positive. So which direction are you considering positive?
I don't get you.
Maybe clockwise, anti-clock. You see, these forces are going to rotate about this axis. Do you get it?
Okay.
So
Yeah.
this is going to cause a rotation like this about it.
Okay.
It's going to cause a rotation like this. This one too is going to cause a rotation like that.
Okay.
So you have to put some sign convention somewhere. You get it?
Yeah.
So you can say that your clockwise, all that going
Mm.
this direction, you make it positive.
Okay.
Very good. So if your clockwise is positive, it means that all the ones that will be going anti-clockwise or that will be counteracting in that direction is going to be negative.
Me too. Okay.
So summation of moment about A, VB will cause what? Is it a positive or negative moment?
Let me see. A negative moment.
A negative moment. So minus VB times the perpendicular distance to the point we are taking the moment times what?
6.
6.
Yeah.
Then you go to 30. The 30, is it positive or negative moment?
I think it's positive.
So positive 30 times 4. Do you see that?
Yeah.
Then plus 30 times what? 2. Do
2.
you see that? Hello?
Yeah, I can hear you.
I hope it's correct what I'm doing.
Yes.
So the sum of these equal to 0. With this, you can find VB by making it the subject. So VB is what? 30 times 4
VB
plus 30 times 2 all over 6. So my VB is to be equal to, do the math for me, or let me use my calculator too.
180 over 6.
So 180 over 6.
Yeah, so you get VB equals 30.
So 180 over 6 is what? 30.
Yes, please.
So it was VB is equal to 30 kilonewtons. Okay. And I said in the first equation, which I drew like this, we established equation 1. We established equation 1, and here is equation 2. So I said VA is here, my VB is here. And you said summation of vertical force equal to 0. From there we had VA plus VB. We had them
60.
to 60. Now I have my VB to be 30, so it means automatically VA is also 30. I hope it's clear.
Yeah, it's clear.
Okay. So let's move on. You now have your reactions. Then the second step is to determine your moment. So in determining moment, so this is how it is. Now have this. Thirty here. Another 32 is here. Here is 30, here is 30. Okay. So in determining your moment, that's the second step. Determine. I can't write everything. Writing is very difficult. Determine
No,
your
no
moment
problem.
and bending moment. So in
I'm
determining
using the
bending
mouse.
moment, you said,
I'm using the mouse.
it's very difficult to write, John. No, I'm using my hand on the touchpad. It's very, very hard. My hand, the friction is
Uh,
hurting my hand. Should have been using some touch pen or something like that, light pen or something.
okay.
Or you get some for the.
Oh no, then with the wireless mouse, but instead, I'm not very cool.
Oh, I get mouse. Mouse there, I get.
Oh,
Okay, so in determining bending moments, what we do is that we cut the section into two and we take one half of it. So when you cut a section, there are two forces that you face. You face a shear and a slope, a moment. So this is the moment, and this is the shear V. When that's their direction when you take the left hand side. So when you cut and take the left hand side, this is where your moment is going. So
okay.
this is M, and this is where your shear force is going, V. When you take the right hand side, it goes like this. Here is your M, your bending moment or your moment. Here is your V, your shear force. Have you seen it?
Yes, please.
Mhm. So from here, what you are going to do is, after cutting, you take one half of it, like one half of the whole thing, the what you've cut. So assume maybe we
Okay.
want to find bending moments at maybe this point, maybe C. You will cut here into two. You will cut here into two, and it will be like this. You have this, your force here. You have this here, and the cut section is here. So here is C. Then this is your left hand side. On your right hand side, there is C also, where you have like something symmetrical. You have this and you have that. So with this is how your arrows are going to show. Like what I demonstrated, it will be like this. Okay, very good. So here is your M, here is your V, your M, your V. Okay. So if you are to determine moment here, this is your bending moment, that's the M, and you have a V here or 30 here. Maybe you consider the distance from here to this place, the cut place, and this one too, the distance from here to the cut place. Do you get it?
Yeah.
Mm.
Uh,
After that,
uh,
after that, you are taking the moment about where you've cut. This is where you've cut. So that's where you're going to take your moment about. So this one, the 30 Newton force will cause this turning effect. This force will cause this turning effect. Have you seen it?
yeah.
And the original moment M is also causing this effect. So you
Yeah.
take a notation for them, maybe you can say this side, those going this side, you can choose them to be positive, you can choose them to be negative, whichever way you like to take it. It depends on you. You get it?
Yeah.
Okay. After that, you just do your normal length times force and you are there. Okay. So let me just take you back a bit. So what we are going to do is to determine the bending moment at various points. So at 30, you can label here. Here is A. The far end is B. So we have to that. Minimize more. Oh, yeah. Oh. Where are they coming?
Okay, okay.
Okay. So at A, B, let me label here C. Label here D. So A, C, D, A, B, C, D. Okay, fine. So you at A, you are going to cut at A. Then you take either your left or your right. When you cut at A, the right hand side is going to be something like this. Here is 30. Then this load comes. Then this load comes. So we have the C here. We have the D here. Here is 30, 30. And this is where we've cut. Okay. So the distances are 2, 2, 2, as you know already. And what is going to happen is that on your left-hand side, there will be nothing there. Because when you cut here, there will be nothing to the left. Do you get it?
Yeah.
So when you take the left, the moment will be 0. You have the moment there, but it will be 0. It won't amount to anything. Do you get it? It's the same thing. The left-hand side is the same as the right-hand side. So you can choose to. You can choose to calculate this whole thing. I said your moment will be like this. Do you remember? When you take it to this side and when you take it this side. Do you remember?
Yeah.
Okay. So I said on the left-hand side, it will be 0. So you can choose to keep the answer 0. But if you are not too convinced, then you have to, which direction will you choose? Me, I'll choose the direction that will be easy for me. I'll choose left. But if you decide to choose right, let's see what's going to happen. You are going to find this M, and it should be equal to this M. Okay. So I'm saying that this direction should be positive, and those coming this direction, I'll mark them negative. Please, is it okay?
Yes, please.
Very good. So if this is the positive moment, then my M is in that direction. So my M is positive. Do you see that? Hello? Hello? Are you there? So your M is positive. Hello? your M is positive, and this 30 kilonewton load is going to cause, we are taking the moment about this point. This 30 kilonewton load is going to cause like this. This 32 will cause like this. And this one too will cause like this, about here. Okay. So my M is positive. It's in this direction. So I come. My 30 kilonewton load, which direction is taken? So the 30 kilonewton load, as I said, is taking this direction. And with that, I'll choose a negative. So it's negative 30 times the distance from here. That's where you are taking your moment, to where the force is acting. So 30 by 6, then the moment caused by this 30 is in this direction. So obviously it is going to be plus 30 by its distance from this end, where we are taking the moment about, to where the load is acting, which is 4. So 30 times 4. Very good. Then I think that's all. No, wait. It has left with this 30. Okay. So that 32 is in this direction. It's in this direction. And that one too is going to be positive. So plus 30 times its distance is 2. The whole of this should be equal to 0. Okay. Can you hear me? So my M, I'm going to end up getting, so let me have my calculator here. I'll send everything, the calculations, to the other end of the equation. So I'll be having 30, the 30 times 6, 30 times 6 plus 30 times 4. No, here will rather be minus, because after it crosses the equal sign, minus 30 times 4 minus 30 times 2. Okay, so this is going to be what? 0. Have you seen it? So at the end of the day, it has proven that both the left-hand side and the right-hand side amount to the same thing. So it is better you choose which side will work best for you, or will make your work faster. Are you there? Okay. So from here, I'll choose the left-hand side, since that will help my speed, or my speed in the work process. Okay. So bending moment at A as I said earlier, wait. Bending moment at A is equal to 0. Let's go to C. So here is 2 meters, 2 meters, 2 meters. C2 at C. So at C, maybe. At C. So what am I having at C? So when I cut at C, I'll have my 30 here. This load, when I cut through it because the point load, it will vanish. So I wouldn't have any load over there again. Okay. I'll have my 2 meters here. And my moments will come. This is my moment. Okay. So here is my M. Let's try and find the value of M, and that will be our bending moment at C. So the value of M, you have to choose a direction for your work. I'm choosing this direction, the direction of M, to be positive. Okay. So the direction of M is positive here. And that means that I'm going to have M to be positive. Then the 30 kilonewton load, about this, it will turn it this way. So that is against the direction I first chose. So this direction is negative. I said this direction is positive. Very good. So M is going to be minus, because this direction, the 30 kilonewton load direction is against my chosen conversion. So M minus 30 times 2. And that's all. So I sum everything to 0. So what is my M? My M is going to turn out as 60 kilonewton meter. Very good. So it means that bending moment at C, my bending moment at C is going to be 60 kilonewton meter, or just write 60. Okay. Then let's proceed from here. From here, we come here at D. So at D2, this is D. When you cut through D and you take one of the sides, so I'm now going to cut through D. Here is B, here is where my C is. There is a load there, C. And here is my A. Okay. So when I cut through point D, I'm going to have one of the sides to be something like this. Here is 30, and there will be no load here. Don't be deceived, because we've cut everything together with the load. And here will be D. The distance is 2 meters. Okay, so at point D, I said when I cut and take to the right, I'm going to have my directions this way. But if I took it to the left, which is like this, I would have gotten something like this. So let me label this, let me label my M. This is my M. Okay. So my M is taking that direction. So it's easy to make my M's direction the positive one. So positive in that direction. And this 30 kilonewton force is moving counterclockwise to the direction of the moment. Okay, so anything counterclockwise is negative here. Okay, so this is what I have. My moment is going to be my M, which is positive, minus 30 times the distance to the point I'm taking the moment about. So 30 times 2, which ends up equal to 0. So what is my M? My M value is going to be equal to 60. So that means that bending moment at D is equal to 60 kilonewton meter. Very good, very good, very good, very good, very good. So bending moment at B, at this point, I said you cut there will be nothing there to the right, but you have this to the left. And I said you choose only one direction, so it really doesn't matter which side you choose. So when you choose to the right, you are getting no moment. So your moment here is 0. My M here will amount to 0. And when you take it this side, you would have to do some calculations, but everything will end up in 0. So it's better you choose the side that will help you best, and that will improve your accuracy levels. Okay, so my M is equal to 0, or my bending moment at B will be 0. Let's quickly draw the bending moment diagram for it. So bending moment diagram, we are just going to plot the moment or the bending moment we've calculated at the various points, and that's going to give us the bending moment diagram. So on the bending moment diagram, you plot the span or the beam length. You plot that against the bending moment you calculated. Okay, so at A here, we had our bending moment to be 0. At C, we had our bending moment to be 60. So you plot 60 somewhere here. At D, our bending moment was also 60. Plot the 60 somewhere here. And at B, it was 0. Plot is here. What you do is you join this, join that, and join here. And because it is up the axis, you put positive here. And the positive sign, when you are going to load it on the conjugate beam, it's going to mean that you have some upward forces. But this is not a conjugate beam. So you end everything at the plus sign. And that is it for the second step, or the first to the second step. Meet me again in the next video, and I'll talk about continuing the second step, going to the third step, and finding the deflections and the slopes on the conjugate beam. Thank you for joining me, and I'll see you again in the next video. Thank you.